In the last class, we were discussing the chapter motion, and particularly in this chapter, we are focusing on some important physical quantities like distance, displacement, speed, velocity, acceleration, deceleration. Among these, the first four have been discussed. And in yesterday's class, we focused on two important physical quantities. One is speed, second one is velocity. Could you tell which physical quantity represents the rate of distance? Which is rate of distance? Or what do you say about the distance covered by a body in unit time? This is speed, is it not? What is which physical quantity represents the rate of displacement?
Velocity.
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 Mohammed Saleh, which physical quantity represents the rate of distance with the direction?
Speed.
Arushi?
Speed, sir.
Timai Kashyap?
Speed, sir.
Yes. Lakshmi Shri?
The speed.
Rate of distance in the particular direction or with the direction.
Velocity.
Direction is mentioned with respect to displacement. Displacement, it is related to velocity. So the rate of distance with the direction is velocity. Just the rate of distance is speed. A rate of displacement is velocity. So which of these two, that is speed and velocity, a scalar?
Speed is a scalar quantity.
Speed.
Is a scalar physical quantity. The reason is it has magnitude only, no direction. Whereas velocity, it's a vector quantity because it has both magnitude and direction. And which of these two may be zero or positive?
Speed.
Zero, positive or negative?
Velocity.
Right? Only we had got this much information. Amulya Seke, what is the system of international unit of speed? Don't turn the page. Don't turn the page.
Yes.
Meter per
Meter per second.
Meter
per second.
Wait. Dheeraj Jaske, only Dheeraj will tell.
Yes, sir.
What is the SI unit of distance?
Meter per second.
Lakshmi Shri, SI unit of distance?
Sir,
Meter.
meter per meter.
She will tell. Lakshmi Shri, you only should tell.
Sir, meter.
SI unit of displacement?
Sir, meter itself.
Meter only. SI unit of speed?
Speed is meter per second.
Meter per second. SI unit of velocity?
Meter per second.
Meter per second. SI unit of time?
Hours.
second.
Second.
Seconds.
SI unit of time is second. Okay. Please do remember the SI units of these physical quantities. Okay. Now let's go for continuing today's class. And in this class, first I'll go for focusing on again the speed and velocity. Just we record the SI units of speed and velocity. Speed is meter per second, and velocity, its SI unit is also same, that is meter per second. Other than meter per second, we will go for using other units like kilometer per hour. In vehicles and all, the speed will be mentioned like this only, kilometer per hour, 50 kilometer per hour, 80 kilometer per hour, is it not? Then Have you heard this? Kilometer per second? We say that velocity of light is 3 lakh kilometer per second. Means light can travel a distance of 3 lakh kilometer just in 1 second. So these are the given. We will go for using centimeter per second, then meter per second, like this. Many are there. Most commonly used units are, one is meter per second, second one is kilometer per hour. Now let us come to know what is the relationship between these two. That is meter per second and kilometer per hour. Yes, students, we know that the unit of speed or velocity is kilometer per hour. Even it is meter per second. Meter per second. The relationship between these two can be found out like this. 1 kilometer per hour, which is equal to, I'm going to convert this kilometer per hour into meter per second. 1 into kilo. Kilo means
1000.
1000
1000.
meter.
1 kilometer is 1000 meter. By here, hour is there. Convert this into seconds. It will be
1 into 60.
60.
360 seconds.
No. 3600 seconds. 1 hour is nothing but 60 minutes. 1 minute, it is 60 seconds. You can write 1 hour as 60 into 60 seconds.
360.
Now, 0. Get cancelled. You get 10 by 6
36.
This can be written as 2 5s are 2 18s are 5 by 18. From this we can say that 1 kilometer per hour is equal to 5 by 18 meter per second. You have to remember this one. 1 kilometer per hour andre it is nothing but 5 by 18 meter per second. I'll make you to write. Lakshmi Sri, Barko madam, nan barasti. 1 kilometer per hour is 5 by 18 meter per second. Similarly, this can also be rewritten like this. 1 meter per second is equal to cross multiply 18 by 5 kilometer per hour. If you want to convert meter per second to kilometer per hour, you can use this. 18 by 5 kilometer per hour. To convert kilometer per hour into meter per second, you can use this statement. 1 kilometer per hour is equal to 5 by 18 meter per second. So now let's move on to some numerical problems. Before that, you just write the side heading. The relationship between side heading, relationship between kilometer per hour and meter per second. Kilometer per hour, meter per second. You may write from here. Even in the examination, it can be given as convert kilometer per hour into meter per second. Next, 1 kilometer per hour is equal to dash meter per second. See, these are the questions to be asked for 1 mark.
So which is the
1
device
kilometer
used
per hour is
for
equal to 1 into 1000 meter by 1 hour is nothing but 60 into 60 seconds. Cancel zeros, you get 10 by 30. Then write 1 kilometer per hour is equal to 5 by 18 meter per second.
Sir, can you please explain meter per second to kilometer per hour?
This is You may write this as it is a class 2. You can write 1 meter per second equal to 18 by 5 kilometer per hour. Hope that you have copied. Manya, completed. Can we move on to numerical problem? Right.
Arushi, lot of sound coming from your side.
Numerical problems. Let me go for taking one by one. First one. Right. Convert the following. Convert the following into meter per second. Convert the following into meter per second. Over.
Yes, sir.
First one in that. Right? It is 90 kilometers per hour. Assume that a bus is moving with a speed of 90 kilometers per hour. It should be expressed in meter per second. Observe it. Let me show you first one. Look at the board. Rohan. Mohita, look at the board. 90 kilometers per hour. It should be converted into meter per second. You all know that 1 kilometer per hour is nothing but 5 by 80 meter per second. Right?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
All right. 90 into 1 kilometer per hour is 5 by 18 meter per second. Should not copy, just observe. Now you can cancel it. 1 is up. This is 18, 5 is up. Right? Oh, very good.
Yes, sir.
I want to place expression. Don't sit like an idol. Good, good boy.
25 meters per second, sir.
5 is up. 25 meter per second. So therefore 90 kilometer per hour is equal to 25 meter per second. This is a simple conversion. Okay, copy this. I'm getting good response from Gaurav S. Good boy.
Akshay, what do you want?
Hope that you have finished. Yes.
Yes, sir.
Okay. Then next I'll give you another one. It is also simple. And you should go on writing with it. Next one is, it is simple one. 72 kilometer per hour. Sanjana ji, tell this directly, quick as possible. Don't calculate.
Sir, can I say?
Wait. Mind calculation. Mind calculation is enough.
72 kilometer per hour is equal to 20.
Wait. Don't speak. See, let me tell you how this is. You are going to convert this kilometer per hour into meter per second. 5 by 8 into 5 by 18. Don't speak in between. 72 into 5 by 18. 18 ones are 18. 4s are 4 5s are 20. Is it
20.
not simple? Sanjana?
Yes, sir.
Very good. Okay, so my simple one, Kotaga, you should try your best to calculate in your mind only. Now write it. It is 72 kilometer per hour. This is equal to 72 into 1 kilometer per hour is 5 by 18 meter per second. Then cancel it. 1 za, it is 2 za, sorry, 4 za. 18 4 za, 17. 4 5 za, 20. 20 meter per second. Therefore, 72 kilometer per hour is 20 meter per second. I'll give you one more. Afterwards, we'll move on to some other numerical problems. Before that, just directly you may try your best to tell. I expect from Shamita. Shamita, suppose we have given a speed of 108 kilometer per hour. Convert this into meter per second.
Sir, can I?
Sir, shall I?
Wait. She's telling. 108 into 5 by 18. 18 ones are 18.
6.
I expect from Yashwant.
30 meter per second.
30. 30.
Yes, sir.
Very good. See, 108. When you divide this by 18, 18 6 are 108. Then into 5, 6 5 are 30. 30 meter per second. Shamita, okay? Yes. And wait. Simple one. Again, I'm going to give you very simple. Let me see how many of you can tell. I expect from Shreyas. Shreyas, 18 kilometer per hour. Convert this into meter per second.
5 meter per second, sir.
Who is that? I'm asking Shreyas.
5 meter per second, sir.
5 meter per second. See, 18 kilometer per hour. That's equal to 18 into 5 by 18. 18 get cancelled. 18 ones are 18 ones are 1 5 are 5. 5 meter per second. Now you write third one. Third one. It is 60 kilometer per hour. 60 kilometer per hour. Shreyas, let your concentration be here. One writing. This is 60 kilometer per hour is equal to 60 into 1 kilometer per hour is, it is 5 by 80 meter per second. Now go for cancelling. Here 2 9s are 2 30s are. This will be again it can be cancelled. 3 3s are 3 10s are 10 5s are 50. 50 by 3 meter per second. If it is terminating, you may continue that. If it is non-terminating, like recurring, you can express that in fraction only. The denominator 3 is there. When you simplify this, you will get non-terminating recurring decimal expansion. Therefore, you will write this as 60 kilometer per hour is equal to 50 by 3 meter per second. Over. Now we are going to second. First time we converted kilometer per hour into meter per second. Now second one, here we are going to focus on finding the speed or velocity of a body when you know the distance or displacement and time. Right. First one. First one, very simple. A bus covers 180 kilometer towards east. 180 kilometer towards east in 3 hours. In 3 hours. find its velocity. Its velocity in meter per second. Even instead of meter per second, they may give like this also. Find its velocity in SI units. Both are same only. Please stop writing and observe. Lekha KB, observe. Have you copied this? Yes. Now look at the board. Sanjana SL, Trupti. And stop Madi and you have to stop it. Look, first one I'll explain. Afterwards, you can write that yourself. Sai Gaurav. Okay. This is the statement problem. Once you go through the statement, it is a bus covers 180 kilometers towards east in 3 hours. The distance covered by the bus is 180 kilometers. It is moving towards east, in east direction. Then to cover this much distance, it will take 3 hours. Now we have to find out its velocity. After finding the velocity, that velocity should be expressed in SI unit, nothing but meter per second. So first, let me write the given information. Look at the board. A bus covers 180 kilometers towards east. Sai Gaurav, here what does 180 kilometer indicate?
Distance.
Very good.
Distance.
Distance, you may take even displacement. The bus is moving towards east. Here I write D is equal to 180 kilometers towards east in 3 hours. Sai Gaurav, what does 3 hours indicate?
Time.
Time. It is T is equal to 3 hours. With this information, you are going to find out velocity. I write it as V. Now, calculation. Observe. We know that formula used to find out velocity. It is S by T. V is equal to S by T. Even
Displacement by
go
time.
for
Displacement by time.
Displacement by time.
Sir,
distance by time. Even you may take distance by time also. As the body moves along a straight line. You get towards east, it is moving in a straight line. Hence, you have also used this formula, D by T. Now, this is equal to where D is 180 and T is 3. Okay. Distance is 180 kilometer and time is 3 hours. Cancel it. It is
60
kilometer.
60 kilometer per hour second.
Okay. 60
Sir, answer is 50 by 3 meter per second.
Babel, I told you not for writing. This is equal. We found out the velocity, but it should be in meter per second. Then 60 into kilometer per hour. It can be done as 5 by meter per second.
Answer 50 by 3 meter.
50 by 3.
Look at the board. 6 3s are 6 10s are. So 10 5s are 50. 50 by 3 meter per second. Conclusion. Therefore, the velocity of the bus is 50 by 3 meters. Now, hope that you have understood. Please go on writing. Write the document. Narisa, go for writing.
Yes, sir.
Right. D is 180 kilometer. Time taken to cover the distance. It is 3 hours. Right. T is equal to 3 hours. As you are going to find out the velocity, right? V equal to question. Calculation. We know that is the velocity of a body is given by V is equal to d by t. Substitute 180 by 3. It is equal to 60. 60 kilometer per hour. Without fail, you have to mention this unit. Then you will go for converting this into meter per second. Right. 60 into 5 by 18 meter per second. The reason is 1 kilometer per hour is equal to 5 by 18 meter per second. Now cancel. 6 3s are 6 10s are. Multiply 10 into 5, 50. Then 3 as it is, 50 by 3 meter per second. Conclusion. Therefore, the velocity of the bus is 50 by 3 meter per second. Velocity of the bus is 50 by 3 meter per second.
Please cite, sir.
Over up. Next.
Sir, which is the device used to measure velocity, sir?
So we won't go for using the particular device. For speed, we have speedometer. As velocity is direct distance, we will take that and we will go for measuring it. Next one, right? Second one. A car covers. Third one. A car covers. It is also simple one. A distance of 100 kilometers. A distance of 100 kilometers in 4 hours. Find the speed of the car. Speed of the car in SI unit. Speed of the car in SI unit. You can observe that in the previous problem, they only had given. That is, find the velocity in meter per second. But now you have to express that in SI unit is nothing but meter per second. Now, this time, please go and write it.
125 by 18 meter per second.
How much?
125 by 18 meter.
Very good. You are right. Once you go through the statement and write the data with a car covers a distance of 100 kilometers. Here 100 kilometers represent the distance covered by the car. Can be written as D is equal to 100 kilometers. Then in 4 hours, to cover that much distance, it has taken 4 hours.
Time is equal to 4 hours.
Time is 4 hours. Next, you are going to find out the speed. Speed is V. It is question mark. Go for calculation. Shreya, are you writing? We know that the speed of a car, or in general, a speed of a body is given by V is equal to D by T. Where distance is, it is 100 kilometers by time is 4 hours. Now you can cancel it. Ones of 20 paisa. It is 12. The car is moving with a speed of 25 kilometers per hour. Now it should be expressed in SI unit. Nothing but it should be written in meter per second. So let us convert 25 kilometers per hour into meter per second. As 25 into 5 by 18 meter per second. Then it is, can it be cancelled?
No, sir.
No, sir.
No, just multiply. 25 5s are 125 by 18 meter per second. Suppose you want to express that in decimal form. Then obviously you have to divide 125 by 18. How much sir you take? Very good. How much sir?
6.95.
86 sir.
6.94 bar.
Not it.
Observe. Now 50 minus 8 is 7. Then 1 will remain. 17. You may put decimal. Take 0. 170. Now 18 how much sir?
18 nines are
9 sir. How much?
162.
6.94 bar.
152. You'll get 8. Check 0. It will be 80. 18 how much sir?
4 sir.
18 5
5
18
4 the
4 za
4.
Sir, 4.
So 6.9. After decimal, 2 digits are enough. Now we express that in decimal form.
6.94 bar.
4 is
4
the
bar. No. It is 18. 18 fours are 72. Again 8 will remain. Yes. 4 and so on. Repeated, I have been telling, if you want to express the final answer in decimal form, you may take only 2 digits in the decimal part. So we can write it as 6.94 meter per second. Now you may write the conclusion. Therefore, the speed of the car is 6.94 into 10 raised to the 6.94 meter per second. Written up?
Yes, sir.
Okay.
Yes, sir.
These are very simple one. Now I'm going to give you one important statement which was given in the examination. Right. The statement is a train 100 meter long is moving with a velocity.
sir fourth question
Third one. Oh, sorry, fourth one. That's right. Fourth one. A train 100 meter long. 100 meter long is moving with a velocity. Is moving with a velocity. Of 60 kilometer per hour. 60 kilometer per hour. Full stop. Find the time it takes. The time it takes to cross the bridge of 1 kilometer length. 1 kilometer long. The students, just observe here. Once you go through the statement, a train 100 meter long is moving with a velocity of 60 kilometer per hour. Then we have to find out the time taken by the train to cross the bridge whose length is 1 kilometer. Here you are going to find out the time. We have a formula to find out the speed. V is equal to d by t. And as you are going to find out the time, t can be written as t is equal to d by v. E formula use. But do you know the distance covered by the train?
No, sir.
Namit?
1 kilometer.
No, sir.
Kilometer.
No, sir.
1 kilometer.
1 kilometer.
1 kilometer.
Lavanya, could you tell?
1
Arushi, could you tell?
Sir, 100 meter.
Manya, what is the distance covered by the train?
101 kilometer.
101 kilometer.
Yes, maybe.
Actually, you know the concept. You're not telling the proper number to represent that distance.
Sir, 1 kilometer, 100 meter.
Oh, it's a
Now, let me
kilometer.
tell you that. Look here.
1100 meters.
Wait. Assume that this is, hope that you can understand. This is the bridge, okay? And here is the train. This is the train. You all know that the length of the train is 100 meter. This is 100 meter from here to here, 100 meter. And you also know the length of the bridge, it is 1 kilometer. This is the length of the bridge. And this is initial position, initial point of the bridge, and this is final point. If the train has to cross the bridge, what is the total distance it has to cover?
900.
1 kilometer.
1 kilometer.
1100 meters.
1 kilometer.
1
Somebody
kilometer.
tell. I think
1000
1
meter.
kilometer.
1100 meter.
100 meters.
1100 meter.
Enough.
1000 meter.
Enough. Just look here. If the train has to cross the bridge, its last compartment should also cross this point. Is it not? So it will move from here to here, then plus 100 meter. So total 1 kilometer plus 100 meter. Nothing but 1100 meter. Did you understand? So this is the total distance covered by the train. Total length of the bridge is 1 kilometer. Its last compartment has to come here. Then here, 100, it has to move 100 meter long. So 1 kilometer plus 100, it is 1100 meter. This is the total distance. Next, it is moving with a speed of 60 kilometer per hour. So speed is known and the distance covered, that is also known. Then you can go for finding the time. Let us find out. Right way. Read the data. It is. I am going to take the total distance covered by the train. Virupakshi. D is equal to, it is, I'll write 1 kilometer plus 100 meter. I'll write it all together. This is equal to 1100 meter. Next, its speed is known. V is equal to 60 kilometer per hour. Okay, here distance is in meter, in speed it is kilometer per hour. Therefore, it should be converted into meter per second.
Sir, 60 kilometer per hour is velocity or speed, sir?
You may take any one of these two as it is moving in a straight line. So 60 into 5 by 80 meter per second.
by 3 meter per second.
50 by 3.
50 by
By 3 meter per second.
50 by 3 meter per
50 by
second. You are going to find out the time T is equal to question mark. Now let's want calculation. We have a formula to find out the speed or velocity. We know that V is equal to D by T. We want time, solve time. T is equal to, it is D by V. This is equal. Now you may go for substituting. Distance is 1100 by speed is, it is 50 by 3. Let me continue that here. This is equal to here 1100 into, okay, in the denominator we have 50 by 3. You may go for taking its reciprocal. Reciprocal is 3 by
3 by 50.
3 by 50.
3 by 50.
0, 0. Get cancelled. Divide 110 by 5. 5 2s are 10. 1 will remain, it becomes 10.
66.
5 2s are into 3. 22 3s are. It is 66.
66.
What is the unit of time?
seconds.
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 You have written everything in SI unit only. Distance na SI unit or even
Minute.
speed also written in SI unit. Hence, time should also be in SI unit. That is 66 seconds. The conclusion. Therefore, the time taken by the train to cross the bridge is 66 seconds. Nothing but 1 minute 60. Sorry, 1 minute 6 seconds. Right now. Therefore, the time taken by
1 minute.
the time taken by the train to cross the bridge is 66 seconds. 66 seconds. Now we'll move on to another one. Bora. Right. Next one. An electric train. An electric train. The electric train is moving with a velocity. Is moving with a velocity of 120 kilometers per hour. Moving with a velocity of 120 kilometers per hour. Full stop. How much distance? How much distance will it cover? Will it cover in 3 minutes 20 seconds? 3 minutes 20 seconds. Observe. Look here. In the previous problems we come across finding the velocity or speed. Second one, finding the time. Now, this statement is related to finding the distance. Once you go through the given state, it is an electric train is moving with a velocity of 120 kilometers per hour. So here, its velocity is given, velocity of the train. You are going to find out how much time, how much distance it will cover in 3 minutes, 20 seconds, which means that the train will move with a speed of 120 kilometers per hour for 3 minutes, 20 seconds. With this information, we have to find out the distance covered by the train within that time. First, let's go for writing data. And before that, once you observe, you all know that 120 it is distance, 120 kilometer per hour it is velocity. This is in kilometer per hour. And 3 minutes 20 seconds. This is time. It is in minute as well as second. Dear students, when you are solving any problem in physics, you have to express the units of the physical quantity in the same, that is SI unit. Let's go for writing. Right, data.
20,000 kilometer by 3.
Distance 120 kilometer per hour is there. But in a minute is that. That is why I am going to convert this into seconds. We can write 120 into 5 by 18 meter per second. You may cancel it. It is 6 3s are 6 2s are 0s. Now this can be written as 25s are 100. 100 by 3 meter per second. This is the velocity. Time is given. Let us write the time. T is equal to 3 minutes 20 seconds.
200 seconds.
Minutes 20 seconds. This can be written in SI unit. Nothing but in
200 seconds.
3 minutes, it is 180 seconds.
200
180.
seconds.
Plus 20, 200. 180 plus 20 seconds. It is equal to 200 seconds. Right. Distance D equal to question. Let's move on to calculation.
Sir, for 120 kilometer per hour, you have put D, sir. It's velocity, no, sir.
Now let's go for calculation. We all know that speed is equal to distance by time. As we need the distance, we can write D is equal to solve D. It will be V into T, where V is velocity is 100 by 3 meter per second, and time is 200. This is
Sir,
equal
V
to,
represents speed or velocity, sir.
anyone can be taken. Anyone can be taken. Now multiply this. 100 into 200. Here, 4 zeros are
20,000.
there and 2 ones are 2. It is 20,000 by 3 meter.
Meter.
Followed? You can also express this in decimal form. You can write like this. Okay. 3, 6 are 18. 2 will remain 20. 3, 6 are again 18. 2 will remain 20. 3, 6 are 18. 2 will remain 20. It is 6 bar, approximately it can be written as 67 meter. 6,666.67 meter. This is the distance covered by the electric train. Even they may ask you to express that in kilometer. Kilometer only express you just divide this by 1000. It will be 6.6 kilometer.
6.66.
Conclusion. Therefore, the distance covered by the train is 6,666.67 meter. Hope that you are copied. Now I am moving
Yes, sir.
to another very important statement which was given in the examination. Please put double star mark and write. Put double star mark. It was given in the examination. Right. During an experiment, a signal from a spaceship, reaches the ground station in 5 minutes. Reaches the ground station in 5 minutes. 5 minutes. Full stop. What was the distance of the spaceship what was the distance of the spaceship from the ground station right? The signal travels at the speed of light. The signal travels at speed of light. That is, you know that the speed of light is 3 lakh kilometer per second. In SI unit, it is to be written as 3 into 10 raised to the power 5 kilometer per second, but SI unit, you know, it is 10 raised to the power 8 meter per second. Observe. Just look here. Assume that this is the ground station. A spaceship is launched. Okay. This is the spaceship. It is launched from the ground. Then after reaching some height, it sends the signals. And that signal is to be received by the receiver. This is the receiver. Look at it. Now you may go through the statement. During an experiment, a signal from a spaceship reaches the ground station in 5 minutes. This is the spaceship which sends the signal. On signal saying it will reach to the ground in 5 minutes. What does 5 minutes indicate?
Time.
Time.
Good. It is
Time.
Time.
Go through them.
Time.
Enough. Once a now observe. What was the distance of the spaceship from the ground station? Ground station in the spaceship is the distance that should be calculated. They have given the signal sent by the spaceship is moving with the speed of 3 into 10 raised to the power meter per second, 10 raised to the power 8 meter per second, which is the speed of the light. First speed and a signal, it is coming towards the ground. So we have to find out the distance. Let's go for finding. Right. Here time is given. First I'll write that T is equal to 5 minutes. It is not in SI unit. Its SI unit is second. Convert this 5 minutes into second.
300
Come
seconds.
on.
300 seconds.
300 seconds.
300 seconds.
You may write it directly or else you may write like this 5 into 60 seconds.
300 seconds.
It is nothing but 300 seconds. Next, they are given the speed. Speed is V is equal to 3 into 10 raised to the power 8 meter per second. And we do not know what is the distance of the spaceship from the ground. You may take that as D, which is question. Right, calculation. Okay. In data, you can come to know that we have 3 physical quantities: time, speed, and distance. We have a formula to find out the speed. That is, V is equal to D by T. We want distance. Let us solve distance. D is equal to cross multiply T. You will get V into T. Now you may go for substituting. This is equal to, where speed is 3 into 10 raised to the power 8 meter per second. Whereas time is 300. All right, into 300. This is equal to, you may multiply this. 300 into 3 is
900.
900 into 10 raised to the power 8. Just look at it. Here 900 is there. 900 can be written as 9 into
100.
100. And 100 can be written as
10 square.
10 square. So I'll write 900 as
9 into 10 raised to the
into
power 10.
10 square into 10 raised to the power 8 as it is. Observe, here we have these two numbers which are in exponential form.
Add.
Bases are same. Then what should be done with the powers?
Add.
Addition.
Added.
9 into 10.
9. 9 power of 10.
9 into 10 raised to the power 10 meter. Followed? So this is 9 into 10 raised to the power 10 meter. Yeah, spaceship it is at a greater distance. Hence, you can also express that in kilometer. If kilometer convert madodadre, you can write like this: 9 into 10 raised to the power 10 by 1000 kilometer. It is equal to
9 into
9
10
into,
power 7.
very good. Well, observe here, in the denominator 1000 is there. It can be written as 10 raised to the power 3. Take that to the numerator. It is minus 3. 10 minus 3. It is 7. 10 raised to the power 7 kilometer. Conclusion. Therefore, the distance of the spaceship from the ground station is 9 into 10 raised to the power 7 kilometer. Therefore, the distance of the spaceship from the ground station is right 9 into 10 raised to the power 7 kilometer.
Sir, please send yesterday's problem, the minute dial problem, sir.
Which one?
Minute dial.
Yesterday's worksheet.
Which is that?
Fourth question, minute dial, sir.
Okay.
You only sent answers, sir. We one step.
Written up.
Yes, sir.
Now I'll go for rubbing this. So these are the important problems what we solved on speed and velocity. Now we are moving to the next part of this chapter. Just keep observing. I'll go for explaining that. Observe. This is a road, a straight road is there. A boy starts walking from this point. Fahim, where are you? Okay. This is the initial position of a boy. Start moving. Start walking. And before walking, what was his speed?
Zero.
Zero.
Right? Look here, speed, it is 0. Now, in 2 seconds, he covers a distance of 5 meters. In next 2 seconds, he covers a distance of again 5 meters. Next 2 seconds, he covers a distance of 5 meters. Now, my question is, could you tell what is his speed? What is the speed with which he has moved in first case? You know
2.5 meter per second.
0.5 meter per second.
2.5 meter per second.
5 meters per second.
2.5 meter per second. 5 by 2 is 2.5. In next is again he covers 5 meter in 2 seconds.
2.5 meter per
2.5 meter per second.
Again,
Per second.
0.5 meter per second. Third case, 5 meter has been covered in 2 seconds. Speed will be
2.5 meter per second.
2.5 meter per second.
2.5 meter per second.
all these cases, you can notice that the speed of the boy or the speed with which a boy is walking, it is staying, nothing but constant. Why it is constant? The reason is
Because it is in uniform.
look here, he is covering the distances in every case equally 5 meter, 5 meter, 5 meter, and for covering 5 meter distance every time he is taking 2 seconds. Understood?
Sir, it's uniform motion, sir.
Wait, just observe.
Yes, sir.
Look here. Here, a boy is covering equal distances in equal intervals of time. Every second or every 2 seconds or every 3 seconds, he is covering the same distance. If any object or any body covers the distance, equal distances in equal intervals of time, then we can say that that body is moving with a constant speed. And this is also known as uniform motion. When a body covers equal distances in equal intervals of time, then it is called
Uniform motion.
constant speed
Uniform
or
motion.
uniform motion.
Uniform motion.
Let us discuss about uniform motion in the later part. You just focus on constant speed. Once I repeat, when a body covers equal distances in equal intervals of time, then its speed is said to be constant or uniform. Now observe it. Look here. Again, this is the part like this, and here is the ball. You start.
Sir.
Assume that he covers a distance of 6 meters in 2 seconds. In next 2 seconds, again he covers 6 meters. Again he covers 6 meters in 2 seconds. Here also you can notice that a boy is covering equal distances in equal intervals.
3 meters per second.
Wait. In this case also, the boy is covering equal distances in equal intervals of time. And when you calculate the speed, you come to know that it is 6 by 2, 3 meters per second. This is 3 meters per second. Even this side also 3 meters per second. So we can say that he is moving with a constant speed. So to say constant speed or constant velocity, we may choose the boy may move or an object may move in a straight path or curved path, whatever it is. If he covers equal distances in equal intervals of time, then it is said to be constant speed. Particularly if that object moves in a straight line, then we go for using constant velocity. Clear? Okay.
Yes, sir.
Observe. I'll go for next one. Again, straight path. You may take even curved. So I take a ball. Let us not leave it. Is the ball. It is its initial position. What is its speed? What is its speed? Zero. Look here. First, to make the calculation simple, I am taking like in 1 second, in first 1 second, he covers a distance of 2 meters. Next,
So should read that, sir.
in next 1 second, he covers a distance of 5 meters.
We should write.
Next 1 second, he covers a distance of just 3 meters.
So should read that.
Second, he covers a distance of 4 meters, like this. Now, what is the speed with which a boy has moved?
2 meters per second.
2 meters per second.
2 meters per second.
2 meters per second. In the next case,
5 meters per second.
5 meters per second. Third case,
3 meters per
meters
second.
3 meters per second. Fourth case,
4
4
meters.
meters per second.
4 meters per
you
second.
can come to know that the speeds are different, or the speeds with which the ball has moved is different for every seconds. Are you following?
Yes,
Yes,
sir.
sir.
You can
Yes,
say that
sir.
it is non-uniform speed. The reason is here the ball is covering unequal distances in equal intervals of time. When a body covers unequal distances in equal intervals of time, then we can say that the speed is non-uniform or non-uniform speed. Even if you consider the velocity, it is non-uniform velocity. Clear? So these are the two important concepts. One is uniform speed and non-uniform speed. Second one is uniform velocity, non-uniform velocity. Now let me give you some situations. You have to tell whether it belongs to uniform or non-uniform. Suppose you are riding a bicycle in the crowded area. Is it possible for you to move with a constant speed?
No, sir.
No, sir.
No, sir.
No, sir.
What type of speed experiencing by you?
Non-uniform speed.
Non-uniform speed.
Non-uniform speed.
Non-uniform.
Non-uniform speed.
Okay. There is a train. On the track, the train is moving and it is covering 60 kilometers in every 1 hour.
Uniform motion.
Uniform motion.
Uniform motion.
Uniform speed.
Uniform motion, nothing but uniform speed. You know, there is a straight road. There is a straight road. And you are riding the bicycle. After some time, you stop pedaling the bicycle, but the bicycle is moving continuously. You are moving continuously. Whether it is constant speed or not.
Not. There is
Non-constant speed.
non-uniform.
Non-uniform speed.
Ununiform speed.
Non-uniform.
Non-uniform speed.
Don't tell. Just listen to me. Once I repeat, there is a straight road. You have started riding the bicycle by pedaling. After covering some distance, after covering just 10 or 15 meters, from then onwards, you stop pedaling. In spite, you stop pedaling, the bicycle is moving continuously. On that road, no speed breakers. It is bicycle is moving continuously. Then what do you say? Whether it is uniform or non-uniform?
Uniform.
Uniform.
Non-uniform.
Non-uniform.
ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ continuous flow ಆಗ್ತಾನೆ ಇರುತ್ತೆ. If it is non-uniform, your speed will be either it should increase or decrease, but it is not at all changing its speed. That means it is moving with a constant speed. But if the road is slow, what will happen? So even if you do not pedal also, the bicycle move continuously, but every time it will be increasing its speed. Speed ಜಾಸ್ತಿ ಆಗ್ತಾ ಇರುತ್ತೆ ಅಲ್ವಾ? When you are moving in the slow road. But when you are moving in the up road, then you will come to know that you have to pedal more and more because your speed will be decreasing. But if it is straight and there is no hurdles, nothing but no speed breakers are there, once you in the initial stage, if you give the speed, it will start moving by itself continuously. It is because of as it moves with a constant speed. Artha aitala?
Yes, sir.
Understood?
Yes, sir.
Now, one more concept. Listen. Listen. This is the road, and this is home. And here is a school building. A boy is moving from his home to school by walk. Sanjana yourself should look here. Boy started moving towards the school by walk because his school is nearby to his home. Look here. First, he covers a distance of around 10 meter in 4 seconds. Then afterwards, he will meet with his friend. When friend, obviously, when you find a friend, whether you move faster or slower.
Slower.
Slower, sir.
Slow, sir.
You have to discuss with them, then you start moving so that next 10 meter to cover next 10 meter, you will take around 6 seconds. Next, after that, again, one more friend is available, and all three will start moving together. Next, they cover 100 meter, 100 meter in 50 seconds. In 50 seconds. Next, after that, around 20 meter. From this point, school is 20 meter away, and to cover this 20 meter will take 10 seconds. Now, my question is, a boy has reached school from his home. My question is, could you tell what is the speed with which he has moved? Is it possible for you to tell
Non-uniform
speed.
he has moved?
Non-constant speed.
Non-uniform speed.
Constant speed.
Non-constant speed.
ನೀವು ಕ್ವಶನ್ ಅನ್ನೇ ಅರ್ಥ ಮಾಡ್ಕೊಳಂಗಿಲ್ಲ.
20 meter per second.
Sir, it is not possible, sir.
2.5 meter per
I'm
second.
asking you very simple question. ನನ್ನ ಕ್ವಶನ್ ಏನಂತ ಹೇಳಿದ್ರೆ, a boy has reached the school from his home. The question is it possible for you to tell what is the speed with which the boy has moved or reached the school?
No, sir.
Sir.
No. What is the reason?
Sir, because there is
Yes, covered.
Always keep
because
moving
it
speed.
has different speed.
Different time intervals.
Because it has different.
Look here. Yes, covered unequal distances in unequal intervals of time. One thing. From this, we can come to know that he has moved with a different speed. Under such condition, to know the speed of the boy, we will go for considering his average speed, because you are not able to tell the particular speed with which the boy has moved. Hence, we will consider the average speed. To find out the average speed, we will take the total distance as well as total time taken by the boy to cover that distance.
20.
Let us count what is the total distance. It is here on right.
140 meter.
10 plus 100 plus 20.
140 meter.
Time taken.
2
4
meters.
seconds plus
140
6 seconds plus 50 seconds plus 10 seconds is equal. What is the
70
total
seconds.
distance?
70 seconds.
140.
140 by 170.
140
2
meter.
meter per
And total time taken
70
70.
70
70.
seconds.
2 meter second.
I'm cancelling. You'll get 2
7
meter
into 7 to 2 meter per second.
This is the average speed with which the boy has moved. Average speed is the total distance covered by a body in the total time. In total time. Got it? Once I repeat, the average speed is the ratio of total distance traveled by a body to the total time taken. Total distance traveled, total time traveled. That is average speed. Followed? Very good. In case of velocity, when a body moves along a straight line, then we will consider the total displacement and total time taken. The ratio of total displacement to the total time taken is called average velocity. So these are the other two concepts: average speed and average velocity. So totally we have come across 6 important terms. One is uniform speed, non-uniform speed. Second, next two, it is uniform velocity, non-uniform velocity. Next two, average speed and average velocity. Clear up? Yes, let us go for writing the information about this. Right here. Quickly. Side heading. Uniform speed. Uniform speed or constant speed. Side heading. Uniform speed or constant speed. Right. when a body covers equal distances in equal intervals of time. Equal
Abhinandan
intervals of time.
Dotre, are you writing or not?
When a body
Writing,
covers
sir.
equal distances,
Writing, sir.
then it is called uniform speed. Uniform speed. Or we can say that the body is moving with constant speed. Example, a boy is riding a bicycle with the speed of 5 meters per second. Means he is covering 5 meters in every second. Next one, non-uniform speed. Non-uniform speed. Non-uniform speed. Right. When a body covers unequal distances in equal intervals of time. Even you may take its reverse order also. When a body covers equal distances in unequal intervals of time, both are same only. When a body covers unequal distances in equal intervals of time, then its speed is called non-uniform speed. Example, a boy riding a bicycle in the crowded area. A boy is riding a bicycle in crowded area. Ora. Next, uniform velocity. Just I'll give you the hint. You may try to write yourself. Look here. Velocity is to be considered when a body moves along a straight line. Everybody should look here. Sorry, Rohan, look here. Velocity is to be considered when a body moves along a straight line. Here, you can write the definition of uniform velocity like this. When a body covers equal distances in equal intervals of time, when it travels in a straight line. Got it? Then its velocity is said to be uniform, or it is called the constant velocity. You can also write the definition in this way. When a body travels in a straight line, if it covers equal distances in equal intervals of time. Once I repeat, when a body is traveling in a straight line, if it covers equal distances in equal intervals of time, then its velocity is called constant velocity. Next, the non-uniform velocity, like this. When a body is traveling in a straight line, if it covers unequal distances in equal intervals of time, then its velocity is called non-uniform velocity. Can you write the definitions of these two yourself? Yes.
sir.
Okay. Now it is time up. Let me go for stopping the class. Today, what are the numerical problems we have come across? Please do practice them today itself without fail. And another last information is, dear students, before working out any worksheet questions, first you have to work out the concepts what we cover. Don't go for working out the working questions directly. You first to practice more better, then only you can move on to solve the problems given in worksheet. Followed? And the last
Side, sir.
Yes, sir.
last information is on coming Thursday. On coming Thursday, you have Google Form online test. Google Form online test in the evening from 7 to 7:45. And excuse me, sir, it is to be given for 25 marks. 25 marks. And the chapter is number systems. Once I repeat, the syllabus is number systems chapter and duration is 45 minutes. That is in the evening from 7 to 7:45. And the date or else the day on coming Thursday. Coming Thursday. It is Google Form test. All are MCQs only, but you need to calculate and choose the questions. I am going to give you such questions in the test. So get ready for that.
Excuse me, side, sir.
Sir,
Side,
sir.
sir.
Side, sir.
Okay, let me stop the class.
Side, sir.
Sir,
Let
side,
us
sir.
conclude.
Side.
No, it is time up.
Yes.
Let's meet again tomorrow. Thank you very much.
Bye.